Good afternoon, everyone. I'm Sheng Xu from China University in China. You are more than welcome to visit Xi'an and the Terracotta Warriors, and us as well. So I'm a lecturer in construction management and also a researcher at the Transport Beam Research Center of China University. It is a great honor to be here and to present to you our ongoing research that we try to develop a personalized safety training system for construction workers. I'm lucky to have Dr. Li to say something similar, and I saw Dr. Bowie here, who talked a little bit about safety issues in the morning. Safety problems stand out in China. In 2016, 74 workers died in one single accident that they fell from a collapsed platform during the construction of a cooling tower in the power plant in Jiangxi province. I came from Jiangxi province, and I'm very sorry for the victims. You can see that statistics say that the Chinese economy is speeding up at a remarkable speed, but number of accidents and casualties do not trending down. Oops, sorry. What did I? Yeah, okay. Most of the Chinese construction workforce are migrant workers. We can see that they do not do construction jobs before. So statistics say that only 7% of them have already received proper training, occupational training before they go to construction sites, and only 0.3% of them are senior technicians compared to 20 to 40% in the developed countries. As human errors identified as the most important leading cause to construction accidents, the migrant workers who are undereducated, low work experience, and low literacy and language skills is a challenge that we need to focus. Sorry. Trained workers perform much better in safety compared to those who are not get proper trained. Classroom-based training has a long history and has repetitively proved effective. However, safety training has already evolved in a lot of ways. For example, localized materials are developed to adapt to the workers' language skills, and virtualized context are being provided with the help of communication technology, and peer-led sessions are also introduced to take the advantage of group pressure, group norms, and so on. But the problems that we see here is text-based training materials not easy to understand for the construction workers, and most of the time the training are not situational oriented, so that even they attend training sessions, they cannot relate what was taught in the training session to what they saw on site. And the training sessions are all often one for all, which means every construction workers get the same training, but they are different. There are heterogeneous workers. That some of them prefer reading, some of them prefer listening to an instructor, and some of them prefer doing things, learning by doing. And some of them knows a lot, some of them doesn't know a lot. Some of them just not willing to perform safely. Some of them gets tired, some of them gets not interested in safety training, and so on. They are different. So what we see here is, can we make changes? Can we make changes in the safety materials? Can we make them novel, interesting, easy to understand, and most importantly, context-oriented? Can we make changes in the safe training method? They could be photo or video-based, not instead of text-based. Can they be easily accessible through their phones or websites to attract high participation? And can we make changes for the heterogeneous workforce so that the training could adapt to the learner's characteristics? therefore, our research aims to provide an online training system that is easily accessible via cell phones and websites, and they adapt to the workers' learning characteristics and personal needs by providing different training materials to different workers, and so that we can improve the effectiveness of training by providing a task-related context. How we do it, this is our research framework. We try to recommend the different safety training materials that is adaptive to their learning characteristics. To do that, we have to develop a personalized resource recommendation algorithm. And on top of it, we have also need to do some fundamental works, including how we organize the training resource. We have to develop a training resource library that organize the safety knowledge in a way. And then we have to assess the construction workers' learning characteristics by introducing the construction workers' learner model. Let's see, firstly, how we organize the safety knowledge. There are explicit safety knowledge and implicit safety knowledge in safety regulations, patrol photos, site experience, and so on. So we analyzed 11 related safety regulations that describes what is a safety behavior and what is not a safety behavior, by saying in what context someone should do something and someone must do something, or someone cannot do something like that. And then we more than 20,000 patrol photos like that were browsed, categorized, and tagged. Site experience were used to validate what we have already achieved. So we organize safety knowledge in the way of knowledge schemas. Schemas is the interrelationship of core concepts. Core concepts are what you can see on site. The structures, people, materials, machines, everything around you. And cognitive psychology said people learn things by identify the core concepts, and then they relate those core concepts with whatever the interrelationships. So we can see here that we develop the safety knowledge into to put them in a scene or the context, and then we relate those core concepts by like comparative words, state words, quantity words, relationships, and stuff like that. And then the implicit knowledge in the patrol photos were then tagged by, we tag out the core concepts and we tag out their relationships. So that this is how we store the safety knowledge. And then by learner model, we try to categorize those construction workers by the type of work or the working trades, the learning motivation, how motivated they are, and by the learning emotions. Are they excited? Are they anxious? Are they tired? Are they whatever emotions that would influence their learning? And then their knowledge levels, how much do they know about safety behavior, and their learning styles, whether they prefer reading, listening, or doing, and stuff like that. This information could be collected by questionnaires or the performance in the safety training. So it's a dynamic assessment of the construction workers. This is something that we do. It's a little bit different from that model, but this is a published work in safety science that we established that they are actually different. Some of them are more about safety knowledge, and some of them just are not willing to perform safety. So with the library and the learner model ready, we can do the personalized recommendation algorithm. Commonly used algorithms include the context-based and contact-based filtering and collaborative filtering. And contact-based filtering matches the user with the resources, and it is highly targeted, but it's not good for multimedia resources. The collaborative filtering can adapt more, but it has a problem of code style that it depends on the evaluation, or in this case, the score of construction workers' training performance. So we propose a hybrid algorithm that use the content-based filtering at the beginning, and then when we have enough scores, we can switch to the collaborative recommendation. And we developed a system that incorporate the library, the assessment of the workers' learning characteristics, and the algorithm as well. This is some of the codes that we wrote. This is some of the user interface. And this is a small video. Can you see? Okay. Can you see if it can play it a little bit? But it's in Chinese, and it's not very. So some of the stuff inside it does not. So can you just fast forward? Just drag a little bit. Yeah, so it's the assessment of the learning characteristics, and then when they log in, there will be the materials recommended to them. But the materials are not incorporated here. It's just something that we just finished coding right now, and we haven't had a good contractor that allow us to validate this system. So anyway, yeah. Back to the slides. And I think that's pretty much it. Yeah. Oh, just conclusion. So as to conclude, we proposed a personalized safety training system for construction workers. We integrate safety knowledge in regulations and practice and put them into safety knowledge schemas. We describe construction workers' learning characteristics with the learner model, and we propose a hybrid recommendation method to adaptively recommend training materials to construction workers. And that's all. Thank you very much.